Good morning, everyone. I am Dr. K. Vidya, Assistant Professor of Physics, Sri Sharada College of Women, Salem. Today we are going to see about general mechanics and classical mechanics. Before we know about the mechanics, first we learn something about physics. So physics is the branch of science. It deals with matter and its relation to energy. It involves study of physical and natural phenomena around us. So here are many examples of these phenomena are formation of rainbow, lightning, falls of things from up and down, causes of sunset and sunrise, formation of shadow and many more. So physics as a subject, it's divided into 6 broad branches such as mechanics, optics, electricity, magnetism, thermodynamics, and atomic physics. Here, a relationship between physics and other subjects. There are many more subjects are related to physics. So here I related only 3 subjects, 3 main subjects: physics and mathematics, physics and biology, physics and chemistry. Physics and mathematics. So physics relates strongly with mathematics. Many physics concepts are expressed mathematically in the form of equations. And physics and biology. So knowledge of lenses in physics. It is used to make microscope. Microscopes are used in study of cells in biology. So physics formulates are used in calculation of magnification by microscope. This is the knowledge of helps to explain the biology. Now physics and chemistry. So here physics has helped in explaining forces within atoms and atomic structures. So you know about the structures of atoms. It's determine the reactivity of atoms as explained in chemistry. And also we are related about physics and geography, physics and technology. Many areas of technology that are requires knowledge of physics. For example, not only uh, in chemistry, biology, many subject. For example, medicine, communication, industrial applications. Here, medicines are used in diagnosis and treatment of disease. Here some technologies are used: X-rays, lasers, scanners are the technologies. In communication, satellite communication, internet, fiber optics are the applications of internet. It requires strong foundation in physics. So not only in mathematics, biology, chemistry. So physics are expressed and related in many subjects. So physics in all involves measurements of various quantities. So here basic concept of mechanics. So quantity is well defined and caused to measure directly or indirectly. No. So here main basic concepts are motion of objects and the force acting on them. It's divided into two main categories. Statistics, so which is the study of forces in equilibrium, and dynamics, which is deals with the force and motions. So motions is the fundamental aspects of mechanics. Force play a crucial role in mechanics, and energy. So energy and work are essential concept in mechanics. So these are the main concept for analyzing real world physical systems. So here main four statements are involved in mechanics. First one, force. So force can be categorized into several types. Before we see about the force, we know something about the laws of physics. So laws of physics govern everything around us. So here mechanics help us to understand the world. How it is means from car to bicycle, mechanics is the everything. So mechanics is the principle or used in all over the all around us. So understanding the fundamental concept of motions and forces is the main source. So mechanics and force are the deals with the study of energy and designed some complex systems. So it is the essential in understanding the world motions of objects to design the systems. And gravitational, electromagnetics, and nuclear force as well as friction, tension, and normal forces. Each force has its unique characterizations. So here main forces of gravitational force. It pulls object towards another, while friction resists motions between surface in contact. So Newton's law of motion. Newton's law of motions. Newton's law of motions are fundamental principles in physics. It describes relations between a body and the force acting upon it. So here there are three laws. First law, Newton's first law, Newton's second law, Newton's third law. As an object act upon by an external force. So unless act upon by the external force is the first law of inertia. First law of inertia, second law of motion. F equal to ma. Force equals mass, time, accelerations. So here assuming mass remains constant. Third one is Newton's third law, law of action and relations. So every action there is an equal and opposite reaction. No. So when two objects interact or they apply force to one another is the third law. Or we can say about when you throw a ball, the ball exert an equal force back on hand is the third law of motions. So it is a simple and help understanding the fundamental principle of motion and forces. Next, kinematics and dynamics. Kinematics is the study of motion without considering the force that causes it. But dynamics explain on effect on motion. Kinematics forces without considering the motion. Dynamics consider the effects on motion. So this is the basic principle of kinematics and dynamics. For example of kinematics, thrown ball. In dynamics, force, when we apply force on the ball. So this is the main fundamentals. So here using study of motion or describing kinematics, study of force and motions, explained the dynamics. Next, energy and work. Energy and work. Energy means energy is the capacity. So to perform the task, to do work, it's defined as force applied over a distance. So there are many types of energy. Kinetic energy, potential energy. Kinetic energy means motions, energy of motion. Potential energy, it stored the energy. Thermal energy, electrical energy, and many more energy are involved in fundamentals. Work energy is the basic principle. Work done on the object is equal to change in its kinetic energy. So work means force applied over a distance. So work is done when the force is applied to an object, it causing it motion. So the work done on an object is equal to the changes in its energy. So it is the work. So work and energy is the main important to help us designing and optimizing the mechanics and process in the process to generate transportations and industries. Clear? So next, momentum and collision. So you know that momentum is the product of mass and velocity. Momentum is equal to mass into velocity, that is P equal to mv. Collision. So there are two types of collisions: elastic collision and inelastic collision. Elastic collision is kinetic energy conserved. Inelastic collision means kinetic energy not conserved. So another one, third, perfectly inelastic. So the example for perfectly inelastic objects or stick together is the perfectly inelastic. So elastic collision, colliding and bouncing off each other. Inelastic collision means for example, a car crash where the vehicle deform and stick together. So it is the understanding the momentum and collision. It helps us to various situations of collisions. Next, so here we see many basic concepts of many general basic concept of mechanics and classical mechanics. So it's provide essential tools to understand our study of force and motions. So you all known about many basic concepts of Newton's law of motions, kinematics, dynamics, force, energy and work. Study of kinetic means study of motion without considering the force. Dynamic means study of motion under the influence of force. So what is force? Force, simple meaning for force is pushes or pulls that cause object to change their motions is the force. So energy and work. So we need energy to do speak, to do work. It is the ability to transfer of energy from one object to another object. No. So these are the main fundamental concept of mechanics. Thank you.